Here we have an average velocity problem, but it's not your usual average velocity problem because instead of going from one number to another number, we're going from a number to 2 plus h. Now that seems kind of weird. We'll still treat 2 plus h like we would any other number using our special average velocity formula up above here. So I'm going to take 2 plus h, which is our value of b here, and 2, which is our value of a, and plug them into the function accordingly. So s of b, or in this case y of b, whatever, would be 45 times 2 plus h minus 16 times 2 plus h squared. Then I say, let's put this in brackets, minus, open bracket, what's s of 2? So I plug in 2 plus h just for starters, then I subtract s of 2. So when I plug in 2, I get 45 times 2 minus 16 times 2 squared. I'm going to need a lot of room for this, so I know you can't really see me, but that's okay because I'm going to probably need all the room on this board. All over b minus a, b being 2 plus h, and a being 2. And that's going to cancel actually right off the bat. The 2 and the negative 2 will cancel right off the bat. Okay, now let's take it down to the next line. The next line is going to involve a lot of multiplication and expansion. So I'm going to distribute the 45 to these two terms. I'm also going to expand the 2 plus h squared here. And I'm going to do some multiplication over here to figure out what this number is going to be. So here I go. I've got 90 plus 45h minus 16 times 4 plus 4h plus h squared. That's just me squaring out 2 plus h squared. Minus 45 times 2 is 90. 2 squared is 4 times negative 16 is negative 64. And this is still all divided by 2. Or sorry, not 2, but h. All divided by h. Okay, next line. Let's do a little bit of cleanup here. I can distribute the negative 16 to all these terms. And make sure you distribute the negative 16. It's not just 16, but negative 16 that's being distributed. So I have 90 plus 45h minus 64 minus 64h. Minus 16h squared, and I'm also going to distribute the negative to these terms. So I have negative 90 and then plus 64, all divided by h. Okay, let's play the cancellation game. I see a 90 here and a 90 here. I see a negative 64 and a positive 64 here. That's all that cancels right now, and I furthermore see a 45h minus 64h. That's going to give me negative 19h, and I have a negative 16h squared. And don't forget, this is still all divided by h. We're almost out of the woods. I'm going to go ahead and factor out an h from the numerator up here. So I have h times negative 19 minus 16h divided by h. These h's will then cancel, leave me with an answer of negative 19 minus 16h. And that is your average velocity. If you want the instantaneous velocity at x equals 2, or t equals 2 in this case, t, we're going to take the limit of this expression as h goes to 0. So this is our average velocity. Our instantaneous velocity is if we take the limit as h approaches 0 of our average velocity. So this is going to give us negative 19 minus 16h. As with any algebraic limit, one of the best things to do is just take that number and plug it right into the function. So if I take h equals 0, plug it in here, I get 16 times 0 is 0, minus, or negative 19 minus that gives me negative 19. So this is your instantaneous velocity. While this over here is your average velocity. So it took a lot of work to get here. There's definitely a lot of algebra going on here. We had to expand this and distribute that and clean up some over here. We had to make sure we distribute the negatives properly. But if you do so carefully and slowly, make sure you follow every single step very meticulously, you shouldn't have a problem getting this answer.